there were four elements. Then there was a dream of Dmitri Mendeleev. Science advanced and we found atoms breaking past the boundaries, transuranium. But does it count? And we're spending thousands to make elements. But do you understand? Some of these elements have use of americium. We're making history. We have made tennessine and filled the 7th row. In ancient Greece there were four elements. There was a dream of Dmitri. There was a dream there were four elements.
Interesting. A book about Parmenides' theory on monism. A world that is completely still? Why, that's impossible. We can't chalk up all the events of the world, from water flowing, speeches being given, friendships made, fires burning, and tragedies, to it all just being an illusion. He justifies this by saying nothing can come from nothing, meaning that nothing can change. But what if instead there are four building blocks of matter that can't be removed from existence, but they can be split up and recombined into different concentrations using forces like love and haste?
Parmenides states it's impossible to change. Movement is an illusion, but I have since found four elements: earth, air, fire, water. Of this I am sure. Love and hate are forces that move the elements, the four elements. There are four elements. There are four elements.
What a brilliant theory! You explain motion without contradicting Parmenides' theory, and you've saved the world from the crisis of the belief of life being an illusion. Thank you. Nice to meet you. I'm Antoine Lavoisier from France. I'm Mr. Smith, a physicist from the United States. What do you study? Oh, me? I'm a chemist. You're a chemist? Yeah. Now, why would you join such a field? In my opinion, chemistry is useless. Why did you leave? Was this something I said? Hello, guys. I'm back. Say, you guys feel like perhaps chemistry should change? To me, it feels like the theory of phlogiston and our alchemic tendencies in general needs to be changed. What? Now you know that we chemists believe in phlogiston, believing that each object has some in it, and it gets released as fire when heat is added. As for metals, melting it releases phlogiston and creates oxides. But if you put charcoal into the resulting oxides, it turns back into metal because the charcoal has phlogiston. But when the metal is heated up, the oxides created way more than the original metal, not less. So what do you propose? By using an electrolysis machine, I was able to split water into two elements, and I believe that there's not just four. There's dozens of them, and they make up everything. Different types of air and metal, and it's crazy. Are you sure chemistry is ready for such a radical change? Oh yeah.
We're gonna go from alchemy to chemistry, cause phlogiston is heresy will revamp the system. 'cause we're the joke of all of academia. From Russia to Iberia, for years it's been medieval. Now it's time for an upheaval. Alchemy, the chemistry, 'cause Phlogiston's heresy will revamp the system to restart the rhythm of chemistry.
I agree. Let's do this. Aluminum here and gold here. That won't work. I need to sleep. I'll think about this more tomorrow. Who knows? Maybe I'll find a way to sort them in my dream.
There was a dream of Dmitri Mendeleev, and in that dream of Dmitri Mendeleev, he forever changed chemistry. It was revolutionary. So here's the elements. How can we sort them? What if we put them next to other elements with similar properties? Oh, people have tried that before. What if we put them by mass? But then it's a list, and people have also done that before. What if we tried to make a table? Each column is a group of elements containing similar properties. And as you go through the table, the atoms get heavier. But it's so hard to make. There's so many variables to consider. And aluminum has no elements in common. How do I know when to make a new line? Wait, these elements react in similar ways, so they should be in a column. And these elements react similarly as well, so they should be like this. And these elements, oh wait, aluminum and boron react similarly. It makes sense if it went like that, but these elements react like this, not like them. What's the explanation? Wait, what if those elements haven't been discovered yet? I leave blank spaces in my table for elements that we don't know about yet. Then everything makes sense. And though it took a lot of skill, he crafted the table still. There was a dream of Dmitri Mendeleev, and in that dream of Dmitri Mendeleev, he forever changed chemistry. It was revolutionary. Revolutionary. Revolutionary.
Eureka! I shall publish my theory so that way the world can organize the elements. Mendeleev, I'd like to talk with you about your theory on the periodic table. Sure, you claim that every element can be placed on a table with 8 columns, but how do we know it's 8? What if it's 10, per se? Well, a table with 8 columns shows a pattern where elements in the same column are similar. But your system requires elements that we don't even know exist. What if there's more elements that we find that will invalidate your table? You expect me to believe your theory made up while you were asleep, where you just assume elements are there that we have no proof of. You're skeptical of me now, but time will prove me right. And what evidence will tell us this? Well, let's look at the blank spots. Element 31, right below aluminum. I'll call it eka-aluminum for now. Aluminum is a light metal with a low melting point. Therefore, eka-aluminum should be the same. I guess we'll just see. Bonjour, Paul Emile. It's nice to meet you. I came to France to learn about your work. You say you're trying to find new elements? Sweet. I took a look at the atomic spectrum of different ores to find new elements using a spectrometer. If the spectrum looks unique, it might contain a new element. Have you found one yet? No, but I'll find one eventually. There's gotta be one somewhere. Oh, look at the time. I've gotta go. Good luck. Merci. Let's try zinc blende ore. Let's look at the spectrometer. Oh, it's a new element. I'll name it gallium, after Gaul, which is another name for France. I can't believe I found it! We're here today to congratulate Dmitri Mendeleev for crafting the periodic table. This comes after Paul Emil's discovery of gallium, which Mendeleev predicted the existence of. Mendeleev's eka-aluminum, with an atomic weight of 31, was predicted to have a low melting point and be light. As it turns out, gallium fits all of these properties, proving the existence of his table. I'll admit, I was a doubter, but you were right.
We have found gallium and proved Dmitri. At first we were skeptic, but we can plainly see he forever changed chemistry. He is revolutionary. I must confess, I was under duress. I had to fight the doubters. Sometimes they felt like powder. I must confess, wish that they were impressed. But now it's done with gallium. I was right. He was right.
You think it'll work? I hope so. My calculations say that bombarding plutonium with alpha particles will create element 96. Say, don't you think it's a bit weird that we're making new elements? Maybe a little bit. Like,
in ancient Greece there were 4 elements. Science advanced and we found atoms. Now there's a chance to make elements, Transuranium, breaking past the boundaries, Transuranium, breaking past the boundaries, Transuranium. In the course of all stars all across the galaxy, there exist elements that fuse so happily, and rapidly the atoms get larger, increasing in size even farther and farther. These atoms don't exist on Earth because they would decay by now, and with new tech, we can make them rebirth, make the table larger, make it loud, and now there's a chance to make elements, Transuranium, breaking past the boundaries, Transuranium, breaking past the boundaries, Transuranium. With this new knowledge, Seaborg made plutonium, americium, curium, berkelium, californium, einsteinium, formium, mendelevium, nobelium, and seaborgium, named after himself, expanding the table and adding a shelf. Transuranium, breaking past the boundaries, Transuranium, breaking past the boundaries, Transuranium.
we have just made the 117th element. Let's go!
We have made tennessine and filled the 7th row. It took a lot of skill, how much nobody knows. We have made tennessine and filled the 7th row. But I have one question many consider low. But does it count when these elements were made in a lab? And I don't understand why we're spending thousands to make elements. Don't you think it's a bit much to spend millions on atoms that dissipate in seconds? Come on, can't you just enjoy the moment? I want to, but does it count when these elements are made in a lab? And I don't understand why we're spending thousands to make elements. But do you understand? Some of these elements have some use, for example, americium. His use in smoke detectors, saving many lives. We're making history. But does it count? Yeah, it counts. We have made tennessine and filled the 7th row. Element 119 is next as far as we know. We have made tennessine and filled the 7th row. Just like everything else, chemistry's changing. So if you like chemistry, it is not a mystery. If you can join the group, then you should be one too. Revamp the system to restart the rhythm of chemistry. I must confess, you might be under duress. You'll have to fight the doubters. Sometimes they'll be real sour. But when it's done, the setting sun, you'll say I was right. It was breaking past the boundaries, and it counts. It forever changes chemistry. It was revolutionary.